let's proceed to continuity of a function on an interval. Okay, a function f of x is said to be continuous on an interval if it is continuous at every point on the interval. Equivalently, if we were able to draw the entire graph of the function on an interval without lifting our tracing pen or without being interrupted by a hole in the middle of the graph, then we can conclude that the function is continuous on that interval. So it's just an implication that this time we are going to have more than one number, but the definition of continuity is still the same. Okay, so what if we have a one-sided continuity? Okay, there are two cases under one-sided continuity. Okay, the first one is a function f of x is said to be continuous from the left at x equals a if f of a is equal to the limit of f of x as x approaches a from the left. Whereas the second condition is a function is said to be continuous from the right at x equals a if f of a is equal to the limit of f of x as x approaches to a from the right. Okay, now this leads us to the definition of continuity at a closed interval. So a function whose domain includes the closed interval from a to b is said to be continuous on the closed interval from a to b if and only if it is continuous on the open interval from a to b as well as it is continuous from the right at a and continuous from the left at b. So we try investigate the continuity of the function f of x is equal to negative x squared plus 2x minus 1 at the following intervals. We have a from negative 1 to 1, b from negative infinity to 0, c from 0 to positive infinity, and d from the closed interval, okay, the closed interval from 2 to 3. Okay, now we apply graphical method in determining whether the given function is continuous on these intervals. Okay, first we have from negative 1 to positive 1. Okay, we plot first those points. Okay, since we have an open interval, the endpoints negative 1 and positive 1 are not included to or not to be considered, okay, as part of this. So we evaluate whether the function is continuous, okay, from the left side of positive 1. So that means we will trace the function from this point, okay, up to 1. Okay, then we also trace, or by the way, we see that the graph is continuous from the left of positive 1. Now let's check if the function is continuous also from the right of positive 1. So let's trace. So from the left of or from the right of negative 1, we can see that we can completely trace the function without lifting our pen. So therefore, we can say that f of x is continuous at the open interval negative 1 until positive 1. Okay, now let's have the second interval. This time we have from negative infinity to 0. So we have 0. Here is the point where x is equal to 0. Now we trace, okay, from the left of 0 from negative infinity to 0. We can clearly see that we can trace the graph without lifting from the left side of 0. Therefore, we can say that f of x is continuous on the interval, okay, from negative infinity to 0. Okay, what about the third interval from 0 to positive infinity? Again, we plot again the point having x equals 0. Then we have from 0 to positive infinity, we trace that from 0 to positive infinity. As you can see, we can trace the graph without lifting our pen. We can trace the graph continuously without lifting our pen. So that means that f of x is continuous on the interval, okay, from 0 to positive infinity. Now, what about if we have the closed interval 2, 3? We plot these points wherein we have 2, 3. Okay, so we check whether the graph is continuous from the right of 2. Okay, so here we trace right of 2, that includes here. Okay, then we trace again from this function from the left of 3. Okay, so we can see that we can trace the graph continuously from the right of 2 and from the left of 3 without lifting our pen. So therefore, we can say that f of x is continuous on the interval from 2 to 3. Now let's have example number 6. Investigate the continuity of f of x equal to the square root of 4x minus x squared on the interval from negative 2 to positive 2. So here is negative 2, then positive 2. So we graph. Now, from the left of positive 2, we can trace that. We can trace the graph continuously without lifting our pen until we reach positive 2. Now, let's see if we can trace the graph without lifting our pen from the right of negative 2. Now, let's have this. Okay, we trace the graph from the right of negative 2. We can see that we can trace the graph completely without lifting our pen continuously. So therefore, we can say that f of x is continuous, okay, on the interval negative, okay, on the closed interval negative 2, from negative 2 to positive 2.